we had a look on the motor control circuits. So we have a microcontroller in here, and we have an electric motor, and then some transistor circuit to control the current which is flowing through the motor. A simple circuit. For that circuit, we need to generate these control signals from the microcontroller. And we are going to have a look at how we program the microcontroller in here. So for driving with the microcontroller, we need a pulse width modulated out. This we can pulse width modulation output. This we can create with a certain class out of the class library from the operating system embed OS. So that's used for driving the motors. And then in between the microcontroller and the motor, we need some kind of circuit. And we can have a look on the course page. There is also the document recommended modules. And this is the modules recommended for your assignments. And in this document, we can go, it starts with the sensors, but we can go down to, from the sensors to electric motor drives, like this. And I have selected here a few modules which are easy to use with our microcontrollers. So typically in these modules, there is just the power electrics in here. And then our microcontroller needs to somehow provide the signals which are driving the motor in both directions. These are typically these 8-bridge drivers, so capable of driving a DC motor in both directions. And if you look at the list, I have indicated here what is the maximum voltage, what is the maximum current, and then if it works with our 3.3 volt input outputs from the microcontroller, and also the price. So €8 for the printed circuit board and this product. The chip there, which is driving the current, is so small that we can't even see it in here. It's in there anyway. Then this is a little bit more traditional. The driving chip is larger. This is not that modern as that one. So in this one, we can see the driving. This is the motor driver circuit. Integrated chip with the 8-bridge driver. And then there is a heat sink, which is dissipating the extra heat. When it is not switching the current with 100% efficiency, it's heating a little bit. There are the supply connectors, and then connectors for 2 motors, so motor 2 and motor 1. So it's capable of driving 2 motors, so it's a 2 times 2 amperes. Maximum current, maximum voltage 46 volts. So if you take 46 volts and 2 amperes, you get roughly 80 watt of power out of 1 motor, and you can drive 2 of those motors. €15 for that one, but then you can also get a similar one with €8 from another supplier. If you select something like this, you need to be careful on checking that these are the control pins. There are a pin here and a pin here and a pin here and a pin here. And in this one, there is the pin sign here. So you need to check which version you get. But for these pins, the microcontroller is providing the control signals. And then there are other options, a little bit more power. So 7 ampere continuously, 50 ampere peak. There are the transistors visible on that printed circuit board as well. Still another one. Still another one. So continuous current 2 times 15 ampere. And so on. But if you then go for these all are for the DC motors. So DC motor drives, driving with always with an 8-bridge So those 4 transistors. But then if you drive an alternating current motor, then you need something like that kind of device, which is a little bit larger. And then it's got its own, let's say, user interface with the push buttons and the display in here. So you pay something for a small motor, you pay something like 100 euros for this one. So maybe 100 euros for your motor driver, 100 euros for your motor, and then you still need a gear there for reducing the rotational speed. So maybe still another 100 euros for the gear as well. But the prices really vary from 100 euros to 10,000 euros, depending on the power, so the size of the motor. And then if someone is driving very traditional servos, like in all kind of hobby applications, so these are the servos, so-called servos. So-called servos, those are from the hobby market, not from the industrial. Industrial servos are different. So that's a servo. And then we are using a certain kind of integrated chip to drive the servos. So there is the microcontroller, and then there is the chip in between, and then we drive the servos with that one. So my example is in here, a chip which can drive 16 servos at the same time. And then the price of this board here is 21 euros. That's the driving board, driving 16 servos at the same time. Right, but then all these DC motor drivers, these will need a control signal from the microcontroller and the control signal for adjusting the speed as well, the speed and the direction. And for the speed, you need the pulse width modulated signal. And then we go for the embed OS class PWM out.